Hello, my name's Dave Hicks. Today we're going to talk about acids and bases and pH and hydrogen ions. What you should be able to do by the end of this is define what pH is all about, and then calculate the pH of a solution if I give you the concentration of some acid, or work backwards and determine the concentration of hydrogen ions when given a pH. Now this particular video is going to be really short and sweet, meaning I'm going to get right to the point. How to calculate a pH or how to calculate hydrogen ions. There's much more to the story, and if you want to see more about pHs and more about how these acids and bases interact with water, then you should probably check out another video of mine, which I think is going to be called pH, pOH, and kW. But for right now, we're just going to cut right to the point and just show you the mechanics of calculating a pH and calculating hydrogen ions. So pH, what is it? Well, I tell my students that it stands for the power of hydrogen. That's not like power like it's cleaning power or how aggressive it is or how strong it is. No, this power that we're referring to is a mathematical power. Like this down here, where we have 1 times 10 to the minus 4th. It's that power right there, the exponent, that is what are we referring to. pH is defined as minus the log of the hydrogen ion concentration. These brackets right here, if you're not used to those represent concentration in molarity. It's kind of a shortcut for us chemistry folks. The P here is kind of like a function in math class. You remember a function in math class where you go f of x, and you'd have some mathematical operation that you would do that would go along with this, right? So your teacher would give you an x, and you'd go 2x plus 6, and you'd get an answer, and that would be equal to f of x. Well, here, the p is kind of like a p of x. And the p of x is minus the log of x. Now, if you don't know what a logarithm is, you may want to go check out some mathematical video or something like that to try and get a better understanding of what logarithms really are. Logarithms are referring to these powers right here. They take the power and they turn the power into a number. For us, we're going to just take this power and we're going to turn it into a number between 0 and 14 to use with this pH scale. It'll help us to understand if something is acidic or whether it's basic by using this P of H. So let's talk about how to turn this information, the concentration of an acid, how can I turn that into a pH? How do I know what the pH is of this acidic solution that I have the concentration of here? Well, I'm going to just use my formula, and I'm going to go minus the log of the hydrogen ion concentration. Remember that this HCl, it dissociates into hydrogen ions and chloride ions. We saw in another video that HCl, hydrochloric acid, is a strong acid. So every one of these that I have in solution turns into a hydrogen ion and a chloride ion. So whatever the concentration is of HCl in my solution, that's going to be the concentration of my hydrogen ions in solution. So the concentration of hydrogen ions in this solution is 1 times 10 to the minus 4th. Well, I hope you have your calculator ready, because most of the times we can't do a lot of these logarithms in our head. When I was a student, way back when we used to have to walk to school both ways in the snow and in uphill and all those other things, back when dinosaurs were the greatest mode of transportation, we had what we called logarithm tables, and we'd have to look up logarithms in a great big table in the back of your book. But today, you can use your calculator. Look around, I bet you there's a button on it that says log. And all you have to do is press that button and then put in the number just like you see it here. And you should get an answer. Make sure you use the plus and minus sign to make this a minus. That's not a subtraction sign. So go minus log and put that value into your calculator. What you should get is the answer of 4. See, it's the power of hydrogen. So here is the power of the concentration of the hydrogen, and so the pH itself turns out to be that same number, the power of it. All right, well, this one worked out really neat and clean like that. What if we have something different? Let's change this example around a little bit. Take this one off the board, put this one up. I'll do one of these and then I'll give you one to try here, huh? So what if I have another strong acid here, nitric acid, and I'll make up a concentration of this. How about 3 times 10 to the minus 5th molar? And I want to find the pH of this. So again, I'm just going to plug it into my calculator. Minus the log of 3 times 10 to the minus 5th. Crunch, crunch on your calculator, and I hope you get the answer of 4.5. Did you get it? All right. Yep, use a new key on your calculator maybe. Let me try one more with you. I'll let you do this one. How about same acid, and this time we'll do 6 times 10 to the minus 4th molar. You give that a try. Hit pause if you need to. I'll give you a moment. Okay, how'd you do? When I put this in my calculator, I got the answer of 3.2. I bet you got the same answer. All right. How about this? Reverse. How about if we go from finding the pH to finding the hydrogen ion concentrations from the pH? In order to do that, we have to undo the logarithm. And I told you that logarithms are like powers of 10, aren't they? And so to undo the logarithm from the pH, we have to take the logarithm and set it equal to 10 to the minus whatever that logarithm was. And that will undo what we have for the logarithm. To access this on your calculator, you should use the 10 to the x button. Now, many times this 10 to the x button is if you hit the shift on your calculator or the second button on your calculator and then hit the log button, that usually brings up 10 to the x. So the button that I hit is, I usually go in this order like this. I say shift or second, and then I hit the log key, which is really the 10 to the x key now because you've hit the shift button. And then I put in the minus whatever the pH is. So that's the order of things in your calculator. All right, so let's work that with this one here. I have a pH of 5. I want to find the hydrogen ions. So I'm going to go 10 to the minus 5. Shift log, hit that plus or minus button, and 5. What do you get? I got 1 times 10 to the minus 5th. What do you know? Again, what does this stand for? This is the power of the hydrogen. All right, how about 3.25? So if my pH was 3.25 and I want to find the hydrogen ion concentration, I just go 10 to the minus 3.25. Hit that second log, negative 3.25. The answer I got in my calculator is 5.6 times 10 to the minus 4th. All right, I got one last one down here. 9.3 is my pH. Go ahead, hit that pause button if you need to. Work this one out. I'll be right here when you're done. Okay, how did you do? I bet you did great. This one was kind of a unusual answer. Maybe you might be scared because there's maybe a large exponent or something. Do you know what it is now? Yep, I got 5 times 10 to the minus 10th. Did you get that? I hope you did. If not, you might want to go find some practice or maybe check out some other people's videos on this. And I hope that you kind of got to the nuts and bolts of how to calculate pH and calculate hydrogen ions from the pH. And good luck with your chemistry, and I'll see you next time.